Hello, what a lovely day. I'm Lars Brink from Systemate in Denmark, and today I'm going to be sharing how we applied GitHub Actions to a library I'm maintaining. So this is about a library called Lumberjack, and let's see a few features of that library. It's a logging library for Angular. It has 6 configurable logging levels, very robust error handling, and it has a plugin-based architecture, as you see on the right-hand side of the screen. Your application is communicating with the Lumberjack API, and behind that is one or more log drivers. And to demonstrate that plugin architecture built into the library is 2 common drivers: a browser console driver that will display the logs in the browser console, and an HTTP log driver that will use your backend with a simple interface. And the nice thing is that the community provides more drivers, for example, for Azure Application Insights and Google Firestore. And you can even build your own that fits your project, which is relatively straightforward. The library also comes with what's known as Angular schematics, which is used for code generation and code mods. And most importantly for today's talk, it has verified cross-version Angular compatibility. That means that we support multiple major and minor versions of Angular from one major version of Lumberjack, version 2.x right now. A bit more about Lumberjack. We have 6 log levels, and Angular has the concept of development mode and production mode. In development mode, all the log levels will be active by default. In production mode, the debug and trace levels are disabled. Of course, this can be overridden using configuration, even to the point that you can configure it on the log driver itself, different from the other log drivers. So we wanted this cross-version compatibility with Angular, TypeScript, and related dependencies. So we looked for GitHub Actions to solve this problem. This is the problem we're trying to solve. As you can see here on the right-hand side, we have a compatibility matrix between Angular CLI, Angular, Node.js, and TypeScript. There's 8 different versions of Angular, supporting 6 versions of TypeScript, 2 major Node.js versions, and that's 30 possible combination of dependencies. So how could we solve this? Maybe a project per combination with a demo application, maybe some unit integration or end-to-end test. This was an initial stable version of our library, and we thought this could quickly become unmaintainable because several versions of Angular are released each year. So the solution was we wanted to use the Angular CLI workspace structure. You see a part of our repo here on the right-hand side. And we wanted a single source code-based solution. So you can see we have the Lumberjack app is a demo app. It has an end-to-end test suite in the next folder. It has a schematics target application. I'll get back to that because it also has an end-to-end test suite. And in the bottom, we see there's a bunch of tools. That's some Node.js scripts integrating our different tool chain in our CI workflow. And finally, so we have this single source code-based solution, and we'll have a GitHub Actions job run per combination of dependencies. So we have in total 50 jobs being run per CI run through. 49 of them are GitHub Actions. The last one is run in SonarCloud. We have between 10 and 30 jobs run in parallel. We're an open source project, so we get basically unlimited GitHub Action minutes from GitHub. So thank you very much for that, or this would not even have been possible. The whole workflow takes around 6 minutes in total, despite 49 jobs at this point. So yeah, that's a pretty neat setup, and we spent a few months perfecting this setup. So that's really nice. The different jobs we see, the build job is the first one. It runs a production library build using the latest versions of all the tools and Angular and so on. And then it uploads a build artifact with that package, which is exactly the package that will later be published to NPM. The lint job runs formatting checks and checks the linting rules. It also uses the latest versions of tools, the tool chain, and all the dependencies. The sonar job generates test coverage and lint reports. Then it uploads them to SonarCloud for further processing. And in the right-hand side, we see the jobs that depend on the build job, and we'll get back to that in a second. The first job that doesn't depend on the build job is the lib or library job. It uses the latest major Node.js version supported by Angular, version 12. And it has all these 8 versions of Angular, which combined have 5 versions of TypeScript supported. So we'll have a CI run for this job per combination of dependencies, as you can see in the right-hand side. It's actually 8 runs in total. They're called matrix legs, the one you saw on the right-hand side before. So for each of those runs, the setup process is that it first installs the Angular version specified by the CI matrix. Then it installs the TypeScript version and other related dependencies. With that setup out of the way, now we can run the main content of this job, which is run the unit and integration tests for our development projects, which are test utilities internally for the library. Then the unit and integration test for the library itself. And finally, we even have unit and integration test for the Angular schematics that are used for code generation and code mods. The next job is the app job. This one does depend on the build job. It has a similar range, but it adds another major version of Node.js because some of these Angular versions support Node version 10 as well. So now we have more matrix legs. We have 16 in total. So it adds another setup step, install the version of Node specified by the CI matrix. It has some additional setup steps here because now we want to test the library from a real application. So TypeScript has this concept of path mappings, which allows code to import code using a package name, but the code might be in the same repo if you set up the path mappings. And we have that in the repo, but we want to delete that so that the next step here makes sense. So we're downloading that build artifact from the build job. That's the package that will ship to NPM. We're moving it into Node modules folder. And the reason for that is this next step, the Angular compatibility compiler. It's a bit of a temporary solution because Angular is currently migrating from the previous generation compiler called Vue Engine to the current generation Angular compiler called Ivy. And right now we're in a situation where Angular libraries are compiled with the previous generation. So whenever an application installs an Angular library, it will have to run it through the NGCC compiler to up-level it to Ivy instructions. So we want to make sure we support that tool as well, as long as it's necessary. With all of this set up out of the way, now we can run the demo applications unit and integration tests. And we will also do a production build of that application. So we have an end-to-end on the unit and integration test level, we have an end-to-end setup, which is as close as you get to a real application. The next job is the end-to-end testing job. We see the same setup as before, only one version of Node. But that is 8 matrix legs in total, and we have exactly the same setup as the previous job. But now we're running end-to-end test using the tool called Protractor. That will use a real browser. In this case, we install the latest version of Google Chrome. Then we run all the end-to-end test for our demo application using the real package bundle. The final job we have is the schematics end-to-end testing job. And we support almost every version here in this setup. There's one detail missing about Angular 9.0 because of the jest issue with TypeScript, but we feel pretty confident that we support even version 9.0 since we are testing 9.1. In this job, we have the same setup as the 2 previous jobs, but now we run the end-to-end test for the schematics, and schematics are used through the command line. So we will have a freshly generated Angular project, the target project for schematics. And then we run from the command line, it's called ng-add. It adds the package to the application, and then it registers the library with Angular and sets up basic configuration. And in the future, we're working on some tools for generating code for using the library, for example, to add your own log driver. So we're doing this for every major and minor version of Angular and TypeScript supported. A few more details about the CI matrix workflow. You have probably seen this setup node action from GitHub before, and you might only have passed it a single version. But here we have the CI matrix in GitHub Actions. So we have two versions of Node. So there will be two jobs, and each of them will specify a version of Node that we interpolate using matrix.node version. So we wanted a similar setup for Angular. So now we have 2 times 8, 16 matrix legs in this job. And we passed to Angular version parameter, we passed the matrix.angular version interpolated. So that comes from the CI matrix run. But if you look closely at this action, it's called ngworker/Angular versions action. It's a package or a GitHub action we created specifically for this library. But as we'll see in a minute, it's meant to be reused across any Angular library for CI setup. So that's pretty nice. So we have it published on the GitHub Actions marketplace. What it does is it accepts this input parameter of the Angular version, and here's an example of a list parameter. It then goes and replaces more than 20 Angular, TypeScript, and related dependencies in package JSON. And each combination of dependencies has been verified by us to still be in a working state, because we all know that over time, dependencies, and especially sub-dependencies, they degrade and sometimes break. But we have found a combination of dependencies that actually working, and we're using that in this library. So to sum up, the workflow we have achieved is this. We have this simple single source code base solution. We have this purpose-built GitHub action that can be reused, and we have already gotten interest from 2 very popular Angular libraries, so we look forward to collaborating with them for them to use our GitHub action. We have a fast parallelized GitHub Actions workflow, and each combination of dependencies is run in isolation, both for our unit and integration test, our end-to-end test, and even the end-to-end test for the Angular schematics. So working with cross-version compatibility is suddenly easy. We can release features and patches across 8 Angular versions, 6 TypeScript versions, and 2 major Node.js versions from a single source code base. And every time we manage to use backwards incompatible API and syntax, it's immediately detected. Well, not locally, but as soon as you push it to the CI, within 6 minutes, you'll know whether it's compatible with all the different versions. And if it's not, you'll know exactly which combination of dependencies has the issue. And you're even technically able to reproduce that using the GitHub action locally. So we're adding verified support for a new version of Angular and TypeScript and Node.js is usually as simple as adding a value to a list of parameters in our CI workflow. And let me tell you, this is an amazing workflow as a library maintainer. Thank you very much for listening. This is my Twitter handle and the URL for the library, Lumberjack. See you all later.